All right, so the next topic here is going to be on systems of equations and inequalities. There are three methods for solving systems. Just be aware of what they are and how to solve them. First one is going to be graphing. So again, when you're graphing, and this is even true even when we're using substitution elimination, be aware that the solution is an intersection point. So if we're graphing, obviously we need to find that intersection point. But even if you're solving algebraically, they intersect at the point AB. Well, and they say find the solution. You're looking for that intersection point. So again, that's what a solution is going to be. Now, if lines are parallel, you're not going to have a solution. We'll hit that a little bit more as we go through our examples. But again, parallel lines have no solution. And if the lines are the same, then they have infinite solutions. And again, we're going to hit both of those types of special cases and what they look like on the SAT here in just a little bit. So just make sure you're aware of it, and we'll go over it here in just a few minutes. So point B is when solving systems of inequalities, most problems will require a graph. Not all, and you'll see the scenarios where it doesn't require a graph as we go through our examples. But other than that one example I'll show you, usually if you see a system of inequalities, you're going to have to solve by graphing, because solving systems of inequalities requires shading, and it's a whole region of answers. So you can't find a region algebraically, you have to be able to see it and show it. Next up, you have to be aware of how to solve using substitution. And again, this method is preferred when one equation is solved for a variable, or it can be easily solved for a variable. So if it just takes a step or two and you can solve for x or y, then again, it's viable to use substitution. If you have fractions on one side of the equation when you solve for a variable, you probably want to end up using elimination. So just be aware of that as well. And then finally, we have the elimination method. This is preferred when both equations are in standard form, that ax plus by equals c, and it's not easy to solve for a variable. If that's the case, we're going to use that elimination method. You may get the coefficients to a variable to match. You may want to get them to match, or to try to get them to match if they don't already. So if they don't match the coefficients for one of the variables, you may need to multiply one or both equations. So anyway, that's going to be your method. So let's go ahead and see what these look like. Again, you can read this little paragraph, but that's something you can do on your own. But let's go ahead and try some of these examples. All right, so our first system of equation problems, I have three of them right up here right now that are all just straight up solve questions. And you will get questions like that on the SAT. They usually show up somewhere in the middle. They're medium level questions. And they're just like this, solve it. There's really no trick to it. You just got to know how to use elimination and substitution efficiently, and then you'll be okay. So number 24, I have actually two 24s. I don't want to change that. So 24a, it's giving me this equation. You just want to pick a method to solve this. So just to kind of show you, you have two options. You could use elimination, which is the way I'm actually going to go. You could also use substitution if you wanted. If you're going to go that route, you'd probably want to solve this second equation for x and substitute, but notice 2y, negative 2y. This is set up for you to use elimination. So what we're going to do is we're going to add these equations together. The reason why I'm adding is that is what would eliminate the variable y in this equation. So I'm going to add 3x and 1x technically. So this is going to be 4x. These cancel, and this is going to equal 16. Therefore, x is equal to 4. 4 times 4 is 16. Once you have x, we can get y pretty quick. However, look at your answer choices, and this is where you can save yourself a little bit of time. The only answer choice that has a 4 in it is going to be answer choice C, so these are automatically wrong. So I don't have to go any farther. Save yourself time when you can. You don't have to normally solve for both the variables. Find one, check your answers, and pick it and move on. And that's what we're going to do for 24a. 24b, another straightforward solving problem. We have 2x plus y equals 1. We have 3x plus 4y equals 14. Neither one of these coefficients seem to match. What I am going to do on this one is I'm going to use a method called substitution to show you how you can do this. Again, elimination would work. I want to mix things up as I go through all these problems, so I'm going to use substitution this time. And the reason why it's viable is because it's really easy to solve this equation for y. All I need to do is subtract 2x from both sides. So I can say y is 1 minus 2x. And I can take this 1 minus 2x, and I can substitute it in here for y. And that's exactly what I'm going to do on this problem. So now that I've done that, let's go ahead and rewrite equation number 2. And again, I'll call this equation 1, equation 2, so you know which one I'm working with. So I'm working with equation 2 right now. So I'm going to go 3x plus 4y. Well, y is now substituted. It is now 1 minus 2x. And that's going to equal 14. I'm going to solve this for x. When you solve for x, we start by distributing that 4. So it's 3x plus 4 minus 8x equals 14. We're going to combine like terms, which is 3 minus 8. So that's going to be negative 5x plus 4 equals 14. And now I can just solve for x. It's going to take me 2 steps. I'm going to start by subtracting 4 from both sides. Move that up here. I got a little bit of space, so that's negative 5x equals 10. Divide by negative 5, we get x equals negative 2. Now, just like I said before, check your answer choices. If there's only one answer choice that has a negative 2 in it, which A does, that's your answer. You don't need to check or solve for y. Even though it's going to be hard to do, you can plug negative 2 up here real quick and solve for y. It's not a big deal. But you don't have to. And you're in a hurry. Don't waste your time solving for things that's not going to matter anyway. So that's going to be all you need to do for 24, and that's going to be A. 25, what they want you to do on this one is solve yet again. But this one I'm going to use elimination. I'm going to jump back and forth here. So the difference with this one as opposed to the other one that we did elimination on is this one I just had to add. I didn't have to do anything. Well, this one we have to manipulate one of our equations to get the variables to match. So the easiest way to do that is to take this second equation and multiply it by 2. What that's going to allow me to do is it's going to allow me to make these coefficients 8. And you have the option of multiplying either by 2 or you can multiply by a negative 2. It doesn't really matter. What it does is it tells you to eliminate if you want to either add or subtract these two equations. Because I already put a negative in there, I'm going to multiply by negative 2. Why not? So equation number 1 doesn't change, so I'm going to write 8x plus 4y equals 12. The second equation, however, does change. It is now negative 8x. Negative 2 times negative 3 is positive 6y. And then negative 2 times 11 is negative 22. So now that we have these coefficients matching, even though the signs are backwards, we can now add these equations and eliminate that variable. These are going to cancel. You're going to get 4 plus 6y is 10y. And you're going to get 12 minus 22 is going to be negative 10. So if 10y is equal to negative 10 and you divide both sides by 10, y is going to equal negative 1. Just like I did with these other ones, check your answer choices. If you only get one answer that has a negative 1 in it, that's the answer you're going to pick for 25. But as you can see on this one, you don't have that as an option. They want the value of x. So again, remember, if it was multiple choice, check them. This one is a grid and they want the value of x. So we have to actually solve for x. So pick an equation. I'll pick equation 1. And I'm going to take that negative 1. I'm going to plug it in. So I'm going to get 8x plus 4 times negative 1 is equal to 12. So when we solve this, we get 8x minus 4 equals 12. Now let's add 4 to both sides. Come up here. I got a little bit of space left. This is going to still be 8x on the left-hand side. 12 plus 4 is 16. So as you can see here, hopefully 8 times 2 is 16, or divide both sides by 8. But x is going to equal 2. And again, that's what we're looking for in this one. They want the value of x. So that's going to be our answer for number 25. So next up, we have 26. This one is kind of long here. There's a lot going on, which makes it a great problem because we deal with a lot of different concepts in the same question. But this one says the graph of a line has a slope of 3. It contains the point 3, 4. So this was giving us a point and a slope. So that would mean we can probably use a point slope form type of equation. So we have a slope of 3 and we have a point of 3, 4, which means I can write the equation for this problem. So I'm going to go ahead and do that real quick. So I'm going to go y minus y1, so y minus 4 equals m x minus x1, which is x minus 3. So with this equation, when you want, and what you'll see in this problem, we're going to want to put it in slope-intercept form anyway, so I'm going to go ahead and do that. So I'm going to distribute the 3, so I get y minus 4 equals 3x minus 9, and then when you add 4 to both sides, we get our final equation, which is y equals 3x, negative 9 plus 4 is going to be minus 5. So there's your first equation, and then we can keep going. We just got started. The graph of a second line passes through the points 4, negative 7, and negative 2, negative 1. So we have 4, negative 7. So our points, I'll just say points plural here. So we have 4, negative 7, and we have the point negative 2, negative 1. Okay, so here we can pick a point, it won't matter, but we do need a slope. So to find the slope, I'm going to go y2 minus y1, so negative 1 minus negative 7, over x2 minus x1, so negative 2 minus 4. Minus the negative for the numerator, that's going to be addition, so negative 1 plus 7 is going to be 6. Negative 2 minus 4 is negative 6, so we get a slope of negative 1. So I'll just go ahead and pick this point because it's smaller numbers. So my equation would start off like this. It's going to be y minus y1, which is y plus 1, equals m, which is negative 1, x minus x1, and that's going to be x plus 2 in this scenario. So distribute that negative 1. So we have y plus 1 equals negative x minus 2. And lastly, let's subtract 1 from both sides. And my equation in this scenario is going to be y equals negative x minus 3. So there is my second equation. So now I have two equations. What they want me to do with these two equations is solve the two lines intersect. That's a solution to a system of equations. When they say the word intersect, you are solving the system. I have two equations. I need to solve them. But they say they intersect at the point hk, and they want you to find both values because you have to divide h and k, which is your x and your y values. So we're going to need to go ahead and do that. So let's do that. So in order to solve this, these are my two equations. I'm going to use the substitution method because they're both solved for y, which means I'm going to take this and I'm going to plug it in for y up here. So my system, when you use substitution, it gives you one equation, which would be negative x minus 3, that's y equals 3x minus 5. So that's your equation you need to solve. I'm going to add x to both sides. So that's going to give me 4x over here. These will cancel. I'm going to add 5 to the other side of the equation. Negative 3 plus 5 is 2. So I now have 2 equals 4x. Let's divide both sides by 4. And x is going to be 2/4, or simplified, that's going to be 1/2. They want you to take h and k and divide them. So I have my x value, that's my h. I need to find my y value. So just pick an equation, it doesn't matter which one. I'm going to use this second equation right here. So I'm going to say y is equal to negative 1/2 minus 3. And I'm writing those as fractions because we need to. So I'm going to multiply the top and bottom by 2 to get a common denominator. So y is negative 1/2 minus 3 times 2 is 6 over 2. So now y is equal to negative 7 divided by 2. So y is this. So now I have my x value and I have my y value. It's a lot of work to get there, and I'm still not done, but I'm almost there. Lastly, we need to go h divided by k, so I'm going to take these two numbers and divide them. So when you divide a fraction by another fraction, we're going to keep the first fraction, change to multiplication, and then we're going to flip the second fraction, so negative 2/7. So again, keep, change, flip. The 2's cancel. You're still left with a negative 1, however, so you have negative 1 on top. You have 1 times 7 on bottom. So negative 1/7 is going to be the value of h over k. So that's going to be your answer for number 26. Number 27, this one wants you to say we have in the xy plane, hk lies on the line. So we have hk, which is a point, lies on the line with the equation of y equals 2x plus b. So I have y equals 2x plus b. And usually if they give you an equation and they're giving you a point, even if that point is in terms of variables, you're usually going to want to plug those variables into that equation. So they're telling me that hk is a part of this problem. Now if they gave you, for example, the point was like 1, 3, well, you would obviously plug in 1 for x and 3 for y, right? Because that would allow you to find b. But they're not doing that. They're giving you a variable because they don't want you to think maybe I should plug in this point. You need to plug it in though. So that's what we're going to do. Again, if they're giving you a point, even if it's variables, plug that point in, please. So I'm going to do that, and I'm going to get k equals 2 times x, which is 2h, plus b. So now I got it. Don't know what I need to do with it yet, but I got it. So that's 27. That's the first part. B is a constant, duh. The point with the coordinates 3h and 6k lie in the line with the following equation. So I have a second equation, which I'm going to write right next to this one. And that equation is y equals 6x plus b. And this one contains the point, and it's 3h, 6k. OK, so I'm going to do the exact same thing here. I'm going to plug that in and see what happens. So here, y is 6k equals 6 times x, which is 6 times 3h. 6 times 3 is 18. So I have 18h plus b. Those are your two equations with those points plugged in for each one. Now, what do we do with it? Well, let's see. The point with those coordinates lie in the line with that equation. What is the value? So here's what we have. We have h, we have the first line in the xy plane lies on a line with this equation. B is a constant. The point with other coordinates lies on the line with another equation, and we want to solve for k and h. So that means we have these two lines. What we're going to do is find their solution. When you're trying to find a solution, what you're doing is you're dealing with a system of equations. These are two separate lines. So what we're going to do is treat this like a system of equations. And what we need to do is the answer wants us to find k over h, which means we need to get rid of b. And if we get rid of b, it'll be in terms of h and k. A couple ways you can do that. You can use elimination, which should be fine. You can use substitution, which should be fine. Either way, if you're going to use substitution, you would solve maybe this one for b, substitute into the second one. I'm going to use elimination. I'll show you what that looks like. I'm just going to go I'm going to go 6k equals 18h plus b, and then I'm going to go k is equal to 2h plus b. And I'm just going to subtract these equations. That's how elimination is going to work. And then the b is going to go away. When you do that, you end up with 5k is equal to 18 minus 2, so 16h. And now the b's gone. They want you to find k divided by h. So if I divide k and h, that means I'm going to go do this, divide by h. Notice what you're left with. If you come over here, you have 5 times k over h is equal to 16. Well, I have to get rid of that 5 still. Well, it's being multiplied by this entire quantity, so I can divide by 5, and those will cancel. So that will come over here. So k over h is equal to 16 over 5. And this is a grid in, so that is going to be your answer for number 27. So again, remember, if they're giving you points to an equation, plug those points in. At this point, no pun intended, but at this point, you had no idea why you're plugging that in. Same thing over here, I had no idea why, but notice we needed to. We needed to get this in terms of k and h. That's how we were doing it, by plugging those points in. So don't forget that. That is a pretty common theme on some of these harder linear equation problems. So that's going to be 27. Next up is 28. This one's giving you two equations, or two inequalities, I should say. And that's going to, first one is going to be 4x plus y is less than or equal to 2. Second one is y is less than or equal to 2x. So in this case, the question is saying, what is the maximum value of y in this system of inequalities? So if you were graphing these, just want to talk about the scenario. So there's going to be a little bit of a shortcut to this problem. And anytime they're asking for maximum or minimum values in a system of inequalities, this same thing is always going to happen. So be aware here. First off, y is less than or equal to 2x. That has a y-intercept of 0, so it would start here, and it's going to increase as it goes off to the right, and it would decrease as it goes to the left, obviously. The second one, these are all positive values, which means it would have a positive x and y-intercept, so I don't care where they are, but they're going to do this. So if you graph these two lines, they're going to have an intersection point somewhere in the first quadrant. Now, from here, you want to find the maximum value of y. Now, you have a grid inbox. Your grid inbox has 4 spots in it for you to type in numbers. What it cannot do is type in infinity. So when you're looking for an answer to this problem, it has to be an actual number. Well, if I shaded, if they end up, because obviously when you do a system of inequalities, you have to shade a region. There's 4 regions here. If I shaded this region on top, the maximum value of y would be infinity. Notice if I shaded to the right, it's going to go up forever, so the maximum value of y would still be infinity. If I shaded to the left, it would go left forever, and it's still going up as you go left. So again, the maximum value would be infinity. But this is the only one that would not give me a maximum value of infinity. It's got to get shaded here, which means the maximum value of y is going for this, for the maximum value for y for the solution, the maximum solution is going to be at this point. It's that intersection point, which means this problem, which is an inequality, I'm going to treat it like it's a system of equations. So that's how we're approaching this problem, as a system of actual equations, not inequalities. So forget the inequalities on this one. I'm going to use substitution. I'm going to take this 2x, I'm going to plug it in for y and solve that system like they were equal to each other. And that will be the maximum value for y. So I'm going to take this first equation. I'm going to go 4x plus y, which is 2x, equals 2. Therefore, 6. And I said that as a y. It's an x. But that's going to be 6x is equal to 2. Divide by 6. And x is the simplified version of 2/6, so 1/3. Now they want the y value. Remember, I said the maximum value of y. So I need to take this, plug it into y. Y is going to equal 2 times 1/3. And that's going to equal, for your y in your answer, 2/3. So again, if they ever ask for a minimum or a maximum value, please just solve it like it's a system of equations, because you can't type in infinity into your grid inbox, or negative infinity if they wanted the smallest answer, regardless. So make sure you're just solving it like a system of equations and you'll be okay. So that's going to be number 28. And next we have number 29. Number 29 is giving us 2 inequalities, but it's not asking for a minimum or a maximum. So they're just saying which inequality contains the solutions. We need to figure out how they're shaded this time. So when you talk about how to solve systems, we have substitution, we have elimination, we have graphing. The only time you really should be forced to have to solve by graphing is in a situation like this, when you have a system of inequalities and it's not asking for a minimum or a maximum value. So here we go. So we just need to graph these, and in order to do that, we just write a quick XY plane. With all of these answers, it looks like they're all like positive, like they're just horizontal lines. So when I graph this, I'm mostly going to be in the first quadrant, it's looking like. So I'm going to kind of sketch my XY axis that way. So the first one that I can do real quick is this vertical line, because when you divide both sides by 2, you get x is greater than 2. That's really easy to graph. So I'm going to go right 2. Again, that's x equals 2, and when it's x equals a number, it's a vertical line. So I'm just drawing my vertical line, and because it's greater than 2, I know it's going to shade to the right. I'm not going to write that right now, but I can tell it's shading to the right because I want to shade the overlapping region here. So I'm going to wait just a second on that. So my second equation is going to be 2x plus 1. So I know it touches at 1, 0, 1. That's your y-intercept. And the slope is going to be 2 over 1. So I'm going to go up 2, right 1. And then up 2, right 1. That's going to put me right there. And that's where it's touching my line. That's my intersection point, which is actually at the point 2, comma, and that's 1, 2, 3, 4, 5. So these touch at 2, 5, and this is another dotted line, although it usually wouldn't matter in this case. unless they had greater than or equal to as your answer choices. So in this one, what I want to do real quick for equation number 1, so I want to pick a test point. So this is equation 1, and the test point is 0, 0, and I'm going to test it and see if it gives me a true statement or not. And this tells me where I should shade this graph, either up or down. And you can sometimes know it messes with you when you start dealing with negative y's. That's why I always like to do test points. But if it's just all positive values, especially positive values for y is greater than, it's going to shade up. And you'll see that with your test point. But if you're ever not sure, pick a test point just to make sure you're doing it right. So this would be 0 is greater than 2 times 0, which is 0 plus 1. So we have 0 is greater than 1, which is false. What that tells me is this point that I tested didn't work, which means my graph does not shade. It better not shade towards that point because that point doesn't work. So I know this graph is shading up, and this vertical line is shading to the right. So if you kind of look over here, I have that 2, 5 kind of in the way. I'm just going to right over it. Here's your shaded region right in here. So remember that point was the point 2, 5. So I want to look at my answer choices now and see which one would fit that region. So as you check each answer, answer choice A says y is greater than or equal to 2. Well, that's this y, this is this line right here, which there's this big gap where there's no answer. So it's not going to be A because that one's not up high enough. B says y is greater than 5. Well, 5 is the y value that your answer's at. So yeah, all your y values for your solutions will be greater than 5. So B is going to be your answer on that because it seems to match the y values for your solutions. The other ones are at 2/5 and 5/2. 2/5 is like way down here, and 5/2 is still way down here. It's 2.5. It's still too small. So again, the only answer that seems to fit the graph is going to be B, and that's going to be your answer for number 29. All right, next up we got number 30. This is yet another problem that has a system of inequalities, which means we're going to most likely need to solve by graphing. This one's not asking for the minimum or the maximum solution. It's asking for the quadrants that the solutions lie in. So we need to just solve by graphing, which means we need to set up our XY plane. Before I do that, let's go ahead, because these are both in what's called standard form. We're going to graph this by finding the x and the y intercept. So the first equation, what I'm going to do is I'm going to find, and this is equation 1, equation 2, so we can kind of keep track of which one. I'm going to start by finding the x intercept, which is the point x0. So we just kind of plot or plug in 0 for y and see what x gives us. And then we're going to do the same thing to find the y-intercept. So let's go ahead and get the x-intercept first. So I'm going to plug in 0 for y. So it's going to give me 3x equals -2. Don't worry right now about the greater than. We're just trying to find points. So here we solve by dividing both sides by 3. And we're going to get the point -2/3 for our x-intercept. So there is 1 point for this first graph. Next up, we're going to get the y-intercept, so 0y, and we're going to see what that gives us. So we're going to plug in 0 for x into this first equation. 3 times 0 is gone, so I'm left with 2y equals -2, so y is equal to -1. So I have 0, -1. So that's you plotting points. That's all you're doing. We're going to do that again for equation number 2. I'm going to find the x and the y-intercept. So equation 2, let's find that x0. Again, now remember, I am now looking at this second equation. If I plug in x, plug in x for x, plug in 0 for y, that y is going to be gone. You're going to be left with x is equal to 2. There's nothing for you to plug in for y, so you don't write anything. So this is going to be 2, 0. And now I'm going to find 0 comma y and see what I get. Again, I'm plugging in 0 now for x, so this is going to be gone. So this is going to be just 2y equals 2, therefore y is equal to 1. So now I can go ahead and graph these. So when I start this, I have my xy plane, so you can obviously draw that. And my points, looks like I'm going to have a point here at -2/3. So I'm going to go -2/3, 0, which is about right here, and 0, -1. So this is my first line. Now this first line should be a dotted line. That honestly doesn't really matter. I'll try to kind of make it dotted though, just so you can see it. All right, so there's equation number 1. You just draw a line going through those 2 points. And then equation number 2 is going to be 2, 0. So I'm going to go right 2, plot a point, and 0, 1. And this one's going to be a solid line, and it's going to look something like that. All right, so next up, we're going to pick our test points. Remember, your test point, as long as it doesn't go through this point, we can use it, is 0, 0. So equation number 1, I'm going to plug in my test point and see if it works. This tells me if I should shade towards that point or away. So equation 1, all these are just going to be 0. 3 times 0 plus 2 times 0 is 0, is greater than negative 2. That is true, but if I plug that point into equation 2, that's this one right here, it says 0 plus 2 times 0 is 0, so I have 0 is less than or equal to 2. Both of these work. What that's telling me is both of these lines are going to get shaded towards 0, 0. So the dotted line gets shaded up, and the solid line has to get shaded down because that's what would approach this point. So when they overlap, they're going to overlap in this region. So what we want to pay attention to as we look at this problem is what quadrants the solution shows up in. So this is quadrant 1. Notice there's a bit of solution in there. Quadrant 2 has some of the solution in there. Quadrant 3, it's barely there, but this section right here, it's there, it's shaded. So quadrant 3 has a solution, and obviously quadrant 4 does. So it looks like all the quadrants contain the solution to this problem. So D says all quadrants, and that's going to be your answer for number 30. All right, so next up, before we start our special cases here of infinitely many solutions or no solution systems of equations, I just want to clarify something on this. So if the question is asking to find values that would give you either infinitely many solutions or no solutions, we want to put them in slope-intercept form. I want to more focus that on the situation where you have no solutions. If you have no solutions, yeah, go ahead and put those in slope-intercept form. Otherwise, you'll see how I'll handle the infinitely many solutions. It kind of depends on how they set it up for you, but you don't necessarily want to put those in slope-intercept form. But with 32, you're going to want to do that, and the reason why is because no solutions means that they're parallel, and I'll talk about that when I do 32, but if you have parallel lines, you have to be able to find the slopes. So that's going to be pretty consistent that you're going to need to put those in slope-intercept form. So anyway, let's go ahead and try 31 and 32, and you can see how this works. All right, number 31, here we go. This one is saying if the system, in this case, they're giving us a system. There it is. There's obviously some variables in there, but they're giving me a very big clue. They're saying the system has infinitely many solutions. So when you have infinite solutions, which this one is saying, what they're telling you is that these are the same line / equation. And that's really what I want to focus on, is they're the same equation. Now they may not look the same right now because one's being multiplied by a constant to make it, bigger on both sides, but these are the same. So what I'm going to do is I'm going to take this bigger one right here. Again, they want us to find B over A. So I'd rather just not change these at all. Let's just go ahead and change these. If we're going to do that, what we need to do is we need to in this case, figure out what do I need to divide 72 by to get 12. And usually all you have to do in this case is figure out how many times bigger is 72 than 12 and figure that out. It's going to be 6 times bigger. So I'm going to multiply everything by 1/6 or divide by 6. It doesn't really matter. So as I write my equations, the first one doesn't change. It's ax minus by is equal to 12. But the second one, that's going to end up being 4/6 or 2/3 x minus 3/6 or 1/2 y, and that's going to equal 12 as well. And as long as you can get these numbers to match, then we now know what A is. A is 2/3, and we know what B is. B is 1/2, really negative 1/2. So in this case, they want B over A. You can't plug in negatives anyway in your answer, so we'll just say 1/2. So I'm going to go B over A. So I'm just going to go 1/2 divided by 2/3. Remember, when you divide a fraction by a fraction, we keep, we change, we flip. So 1/2 times 3/2, and that's going to equal, in this case, 3/4. force, and that's going to be your answer for number 31. And then we move on to number 32. This one's just giving us the opposite scenario. Still got two equations, but this one says they have no solution. So again, as a reminder, no solution. When you see that, then what you need to know is that they have the same slope. The two lines are parallel to each other. Focus on the slope, though. So with this one, I need to find the slope of these equations, and then I probably need to set those slopes equal to each other. So let's go ahead and start doing that. So I'm going to start with equation 1. So I'm going to solve this for y. So the first step I would do, I don't want to write it here, I'm going to take this ax, subtract it. I'm going to move it to the other side. So that would give me negative 4y on the left by itself equals negative ax plus 12. I'm trying to write this in slope-intercept form, so I want to put the x in front, not behind the 12. Now I'm just going to divide both sides by negative 4, focusing on the slope more than anything else. But y is equal to a over 4, because the negatives cancel, times x minus 3. So in this case, the slope is equal to a over 4. Looks like a 9, but it's an a, trust me. Okay, so that's equation 1. I know the slope is a over 4. Now I'm going to go to equation number 2. I'm going to find the slope of that one. I'm going to start the same way. I'm going to take this 4x, move it to the other side. That'll give me negative 3y is equal to negative 4x plus 15. Again, I want to solve this for y. So I'm going to take this negative 3, divide it on both sides. So I now have y equals 4/3 x minus 5. I don't really care about the 5, but that's what it is anyway. So m in this case is equal to 4/3. Now remember, they said these lines have no solution, which means they're parallel, which means the slopes are equal. So they want me to solve for a. I'm just going to go a over 4 equals 4 over 3. This is a proportion problem, so I'm going to do cross product. I'm going to go 3 times a is equal to 4 times 4. So 3a equals 16. Divide both sides by 3. And there's your answer. A, in this case, is equal to 16 over 3. That's going to be answer choice B. And again, that's your answer for number 32. So next up, we're going to be dealing with some word problems with systems of equations. Now, when you're doing systems, just be aware of the types of equations that you're going to potentially have to write. And if you have a template for the types of equations you're going to expect to see, it makes it a lot easier to find them. So the first type of equation, I have equation 1, equation 2, because again, usually you have two equations in a system. But I just want you to be aware that this setup that I'm giving you, it means usually you're going to have a quantity equation, and then for your second equation, you're either going to have a relationship equation or a cost or a dual rate equation. However, that doesn't mean it has to fit that mold. So technically, there's 3 types of equations you can get. They can mix and match any way that College Board feels they need to be mixed and matched. So just make sure you're aware of all 3 types. A quantity is just that. It is a quantity. They just tell you how much of something there is, like say we sold 20 hot dogs. Well, then x plus y is equal to 20. There's no rates attached to those. It's just how much of the stuff you have. A relationship will be something where they tell you, we sold 5 more hot dogs than we did hamburgers. We sold twice as many hamburgers as hot dogs. And again, if that's the case, write that relationship. Usually these are the types of equations when you have this where you'll be using substitution. It depends, but usually it's kind of set up that way because you're solving for a variable. And the third type, I call it a cost type of equation. It's also called a dual rate or a standard form equation. So you're going to see 2 separate rates. I say cost because usually when you have this type of equation, it's representative of 2 costs of different types of items, but it can be something different as well. So don't try to pigeonhole it into just that one scenario. So anyway, those are the 3 types of equations. Make sure you're aware of those 3 types and you can recognize them within a problem. So with that, let's go ahead and try 33 and 34. All right, starting off here, number 33 says Larry, Curly, and Mo have a total of $79. Now, right off the bat, when you see that, more than likely, if you're doing a system of equations, that's a quantity. They're telling you how much they have, even though it is talking about money. And then they start giving you relationships. So here they say Larry has $5 more than Curly. Mo has twice as much as Larry has. And then they want you to solve for C, because that's what I want to call curly. So this is a system of equations. They're actually giving you 3 equations here. Number 1 is that quantity. So Larry, Curly, and Mo, they just have $79. That's how much they have. So I'm going to say Larry, so L plus Curly, C, plus Mo is equal to 79. That's your first equation. That's a quantity equation. Next, Larry has $5 more than Curly. So Larry has $5 more than Curly. So when you see this and you see this equation, you say Larry has $5 more. So we're going to have to add 5 to Curly to make them equals because he has more money. And that's kind of how it's written anyway. The third equation says Mo has twice as much money as Larry has. So Mo has twice as much, again, in this case, as Larry. So he has twice as much as Larry, so we're going to multiply L by 2. Here's your system. You get your system, we need to start solving. Again, the goal here is to solve this for C. We want to know how much Curly has. So if I'm looking, say, at equation number 2, this is equation 2. Again, I got equation 1, equation 2, equation 3. For this one, I'm going to want to rewrite this in terms of C, because I want to, in this case, I'm going to write this as C equals, sorry, make that right, C is equal to L minus 5. What that's going to allow me to do is start substituting. I'm going to plug it in up here, and I'm going to solve this, and I'm not worrying about what I'm solving for at this point, but I can see I can substitute out my C. I'm going to call it L minus 5. This is going to be L plus C, which is L minus 5. And then I'm going to have M, which I already can see is equal to 2L. And what this is allowing me to do is to solve for L. If I have L, I can start finding other stuff. So in this case, I know I have 4 L's minus 5. Well, that's going to equal 79. So now I'm going to keep solving this. I'm going to add 5 to both sides. So now 4L is equal to 84. And then L, if you divide by 4, is 21. So now that I have L, well, in this case, I can get C, because I know that L is C plus 5. So 21 is equal to C plus 5. So I'm going to subtract 5 from both sides, and that's going to give me 16 is equal to C. And that's going to be your answer for number 33. Again, this is a system of 3 equations. And again, if you're stuck at this point, like, what do I substitute for? Just start substituting. It can't hurt you to plug stuff in, and eventually you're going to get there. But if you can see a strategy and have a strategy in place to get it down to one variable, then obviously go that route. My route here was get it in terms of L, and that's what I did. So that's going to be 33. 34 is telling me we have a gas station. They have 2 types of gasoline. We have regular at $2.20 per gallon, and we have premium at $3 per gallon. So they're giving us 2 rates. And they're talking about costs, and usually that's a cost equation, but it's 2 rates. That's the key. At the end of the day, the cashier finds that the receipts totaled $680. So everything dealing with dollars is going to go together. So that's going to be your dual rate equation, and that dual rate equation is going to be 2.2, and in this case we're looking at regular gasoline, so 2.2R plus 3P for premium gasoline, and they said that receipt totaled all the way up to $680. That's your first equation. Your second equation is that they made 280 gallons of gas, or they sold 280 gallons of gas. That is them sliding in that quantity equation. So that quantity is always just going to be X plus Y, or in this case, R plus P. And R plus P, in this case, is 280. So now what we're going to do is we're just going to solve this. Figure out what method you want to use. I'm going to use the elimination method, and I'm going to solve this by multiplying this second equation by -3. That's going to allow me to eliminate the P. And they want you to solve for R anyway, so that's even better. That's going to leave me with these equations written in terms of R. So it's going to be 2.2R plus 3P equals 680. That's your first equation. The second one is -3R minus 3P is equal to 280 times 3, which is going to equal 840. So now I'm just going to go ahead and say, well, I want to eliminate my P. Do I have to add or subtract these 2 equations? Well, to eliminate the P, I have to add these 2 equations. That will eliminate the P. So I have 2.2 minus 3, which is negative 0.8 R. And then I'm going to go 680, and it's plus and in this case, I almost forgot when you distributed, that'd be a negative 840, so it's going to be minus anyway. So I'm going to go 680 minus 840, and that's going to give me negative 160. So now when you solve for r, we're going to divide by negative 0.8 on both sides. So this divided by negative 0.8 is going to be 200. And again, they want to know how much regular gas was sold. There it is. If they wanted to know the premium, I'd have to plug that back in. I can tell premium would be 80 pretty quickly by using that second equation. So either way, it didn't matter. Just eliminate whatever is easier for you. But here, R is 200. That's going to be your answer for number 34.